Hello everyone. So today in this C++ interview series I am going to talk about Heapsort, heap data structure, and then how to use it to do Heapsort. So first I will explain what is a heap and how the Heapsort works, and then I will show how to code Heapsort, how to implement it with C++. Okay, so consider we have an array like this which has 1, 2, 3, 4, 5, 6, 7, 8 elements. Right. So when we build in a heap, so there are two types, max heaps and min heaps. So first, without thinking of any order, let's just build a heap. It's just like a binary tree. So first I'll put the first element, which is 2, in the root, and then 3, 4, 4, like this. And so after 3 and 4 we have 6, and in a heap we always start filling elements from left to right. So 6 and 5 and 9 and 7, and after that we have again another element here which should come under this 1. Now as you can see here, there is no any particular order. We have just insert all the elements into the heap without thinking of what is large, what is small, anything like that. So to make this turn this into a meaningful heap, we have to perform heapifying, which is an operation that makes sure the largest element is always in the top, and we do that by recursively checking all the elements starting from the last non-leaf node to the initial node. So non-leaf node means this 1, 5, 9, 7, these are leaf nodes because they don't have any children, and 6 is the largest, or the largest in the sense in the depth, with the highest depth non-leaf node, because 6 has one child node. So if I start from here, the heapify operation, what it does is it checks with its descendants and check if this node is larger than its child. So if yes, we don't have to do anything, otherwise we have to swap. So starting from here, 1 is already small, so we don't need to swap. And then the next element is, if we go in reverse order, 4. So here if I first check the left child, 9 is large, so we have to remove 4 and swap. So 9 will go here and 4 will go here after swapping. And then if we compare it with the right child, 9 is large, so we don't need to swap. And the next element, when we go backward, the next node is 3. So here you can see, if I check with the left child, 6 is larger than 3, so we need to swap. So 3 should go here and 6 should come here. And if I check with the right, 5 is already smaller than 6, so we don't need to swap. And then this is the final remaining node we have, which is root, that we have to check, and 6 is larger, so delete 2 should go here and 6 should come back here. And after that we have to recursively call the same heapify function on the changed subtree, because after element is changed we have to check if the heap property is violated in any of these nodes. So that means, oh wait, actually we can do it like this. Let me undo. We can get the largest one out of these two and then get the largest value here. So directly, that would be easier. So nine should come here and 2 should come here. So then in this case only this right subtree is changed and we need to call heapify again in this root. So here now 7 is large, so that means 7 goes here, 2 goes here. Right, now this tree satisfy the heap property. Okay, now let's go ahead and implement this in C++. Let's create a new project, console app. Heap. Okay, right, so here I'll add a new, do I need to, no, let's implement it here. First I'll define an array and numbers. Okay, like this, and number of elements, let's say n. We can calculate n using size of number. Actually this should be numbers, not number, because there are many numbers. So numbers divided by number size of first element. Okay, right, now I'll add a new function, void BuildHeap, and we should get an array which contains the numbers and size of the array. So as I said before, we should start from the last index of the array and call and start heapifying backwards. So that means int last, actually last non-leaf node. So we can calculate with this simple formula, n divides 2, sorry, size divides 2 minus 1. So what this gives is, if I go back to this diagram, so here we have 8 elements, and in a binary tree, in the first level we have 1 element, in the second level we have the number of elements in the previous level plus 1 element. Sorry, yeah, not just the number of elements in the previous level, number of elements, total elements in the previous levels plus 1. So here 1 plus 2, we have 2 elements. Here in this part altogether we have 3 elements. In this level we have 4 elements, if that level is complete. So here we have 8 elements, and the last non-leaf node is 8 divided by 2 minus 1. That means 8 divided by 2 means 4, minus 1 means 3. So this is 0th node, this is first node, this is second node, and this is third node. So this is our last non-leaf node. Okay, so from int I equals last, as long as int I is larger or equal to 0, I minus, because we are going reverse as I explained in the diagram. So here now we need heapify operation. Void heapify. So here we need to know 3 things. First one is of course int numbers, and the next one is size, int size, and the next parameter is which node that I want to heapify. So I call it int I, the index of the node that we need to heapify. Right, so if the heap is correct, whatever the index that we need to heapify, if it is already correct, the root node of that subtree should be the largest element. So I'll first put int largest equals I. So this is largest indexed, not the value, index. I call it largest IDX to be clear. And int, now we need to know the index of the left child and right child. So here we can use this small function. If we are considering the second node, left child is 2 into 2 plus 1. That means sorry, this is not 2, this is 1, index is 1, the sixth index of 6 is 1, so 1 into 2, that means 2, and plus 1, that means 3, and the right child is index of node into 2 plus 2, that means 4. So here int left IDX equals 2 into I plus 1. Int right IDX 2 into I plus 2. Okay, now we need to check if this given subtree node satisfies the heap condition, which is the root should be larger than both childs. So here if left IDX smaller than size, so that means we have a valid node here, and numbers left IDX is larger than numbers numbers, let's say largest IDX. If this is the case, that means I is not the largest index is left index. largest IDX equals left IDX. Similarly, we have to check the right one as well. Right IDX, right IDX. So we do the same check. And finally, if largest IDX is not equal to I, that means we have a violation of the heap condition. So we have to swap whatever the element in ith position in ith node with the largest index. So we can use std swap numbers largest IDX with numbers I. So we swap the numbers to bring the largest element into the root of this subtree. Then we have to rearrange whatever the modified part of the left child or right child. So in this case, whatever was the largest index. So Heapify, this is a recursion, numbers size and largest IDX. Right, so that's how we implement Heapify operation. So we have to simply call it Heapify numbers and size and I. Okay, now that's not enough. We need a way to print this whatever the heap we have built. So void print heap. Let's get the array here. Print numbers and size for int I equals 0, I is less than size I plus plus std say out numbers I. Let's add a comma and finally let's add a new line, say out okay. Here let's call BuildHeap on these numbers and the size is n. Oh, why didn't I call this just size? Okay, and after that print heap numbers size. So if I run the program, right, this is what we get. So this is the original array, starts as from 2 and this is the heap. So the largest element here is 9. It is bring to the first element to the 0th index. So it is working, but this is not exactly sorted because this only satisfies the heap condition, not exactly sorted as an array. So now let's see how to sort this. So after building the array, here I'll add another function, void Heapsort. Here also we need to know as inputs, let's get int numbers and int size. So since we have, so I'm going to call Heapsort on a already built heap, not just any array, already built heap. So the first element would have the largest array, largest element, largest value. So here if n equals 0, that means we have reached the end. So we don't have to do anything, just return. If that is not the case, size, if that is not the case, what we do is we swap std swap the first element numbers 0 and the last element numbers size -1. That's the last index. And then we can call again build heap on numbers, and as the size we can give size -1 because we have already moved the largest element into the final index of the array, so we can forget about that. So and at the end we will have the smallest number in the beginning and in the ascending order until the end, right? After that we have to call Heapsort again, numbers and size -1. Okay, so shall we test this? This is unsorted. Then let's call Heapsort numbers size and heap numbers size. Okay, now let's test. Right, so here is the program. So this is the unsorted heap and this is the sorted version 0 2 3 4 5 5 6 7 8 9. So you can see the array is sorted. And remember, Heapsort has a time complexity of n log n, big O n log n, for all worst case, best case and average case scenarios. So usually merge sort or quick sort is more performant than Heapsort. Alright, so I'm going to stop this episode right here. And thanks for watching. So as always, project files will be available for the download in Patreon page. Link would be in the description below. And see you in another episode. Goodbye.